So in this question, we want to find x when minus 12, x squared and 25x form the first three terms of an arithmetic sequence. So how are we going to go about finding that? Because we've got some variables in here, we've not got just numbers. So we know the nth term of an arithmetic sequence is the formula, which is un equals a. A is the first term. Let's write this down here. A is the first term. And we add on to that n minus 1, where n is the nth term. And we multiply that by d, which is the difference. So we want to plug these into this somehow and try and find out when that will form an arithmetic sequence and what the values of x would be. Now, we know the first term is minus 12 because it's given here. So minus 12 is the first term. So we already know that. But n, we know obviously this is the first, second and third, so we know that. But the difference, we don't know. Now, what we do know is that in an arithmetic sequence, the differences are uniform. They're always the same gap. So let's have a look at what's happening with the differences here. So let's try and find d. So we've got x squared minus 12 will be the first difference. So x squared minus 12, that's the first difference. And then we've got another difference, 25x to x squared. So 25x minus x squared is another difference. Now, as their differences are uniform, those differences should be the same. So we can set them equal to each other. So let's do that. So this one here will simplify to x squared plus 12. So we've got x squared plus 12. And that will then equal this one here. So that's 25x minus x squared. So those are going to be the same. So those are our differences. That both should be equal to d. Okay, now if we can get all these on one side, we'll have some sort of quadratic, and hopefully we can try and solve the quadratic. So bring this minus x squared onto this side. So then we're going to have 2x squared plus 12, that can stay here. But to bring this one to this side, we have to subtract 25x and then add the 12. And then as everything's moved over to this side, we got it set to 0, just like as in a quadratic. So now we've got to try and factor out this x, or maybe use the quadratic formula. Now, I think we can maybe factorize this quadratic. So I can see straight away here we've got a big value for x, and we've got a 12 here, and there's a 2 here. Well, straight away I can see 2 12s are 24, so one more, I've got my 25. So we can factor this out somehow like this. So what's my values going to be inside here? Well, as this is large, I want my 2x to be multiplied by the 12, and it's minus. So therefore I'm going to put a minus 12 in there. So 2x times minus 12 will give me minus 24. Now if I multiply by x times minus 1, I'll have another minus x, which gives me my 25. So if I put minus 1 in there, that way then I'll have minus 1 times minus 12 gives me plus 12, minus 24x and a minus x gives me minus 25x, 2x times x gives me 2x squared, so I'm happy with that. So now all I need to do is to solve for x. Well, 2x minus 1 equals 0, or x minus 12 equals 0. So 2x minus 1 equals 0, or x minus 12 equals 0. Okay, right. So let's solve for x here. So 2x equals 1. So therefore x equals a half. And then this one here, just x equals 12. So that's my two values for x. So that's the values of x. So we've found those. So now let's just name the first three terms of possible arithmetic sequences. So let's try x equals a half. So I've got minus 12. So let's try the first sequence for x equals a half. Right, so I've got minus 12. Let's write that in there. Minus 12. And I've got x squared. Well, a half squared is a quarter. And 25x, which is 25 over 2, which is 12 and a half. Okay, let's see if this works out. Let's see what the difference is here. So minus 12 to a quarter. That difference there is 12 and a quarter. Then add 12 and a quarter onto this quarter, I get 12 and a half. So we can verify that that one's okay. Let's try when x equals 12. Let's see what happens there. So my second sequence, x equals 12. Let's see what we got. So I've got minus 12 straight away. X squared, well 12 squared is 144. So I can see straight away my difference here is 156. So hopefully this one will go to 300. Let's see what happens. 25 times 12, 300. So therefore my difference here is also 156. Just write those as pluses because they're increasing sequences. So that's my answers. So x equals a half, x equals to 12. That's the first terms of an arithmetic sequence with the values of that. Okay.